In this activity, we're going to look at different functions. So here, a child gets on a swing, swings for 30 seconds, and then gets off the swing. So here are four situations, and we have to identify the independent variable as time, and then read about these other functions and identify the dependent variable. So we're going to match these to the graphs. So function h, the height of the swing in feet, as a function of time since a child gets on the swing. Well, if I have to look at that, the child's height is going to start off at the swing height, and then it's going to move up and down as they swing. So here, the independent variable is time. And looking up here, the child swings from 0 seconds to 30 seconds. So I can label 0, and the end of it is 30 seconds. And then the dependent variable, independent variable is time. Dependent variable would be height. And we might just put, the child could be like 2 feet off the ground, to maybe they get to like 6 feet. So this is function h. We can cross that one out. So now function r, the amount of time left on a swing as a function of time since the child gets on the swing. So if I think about that, the time is going to be on the x-axis. So that goes from 0 to 30. But if the time left, the child swings for 30 seconds. So the time left would start at 30 and then decrease at a constant rate until 0. So this would be function r. So this would be time left and go from 0 to 30. Or this would be time from 0 to 30, time elapsed. And the dependent variable would be the time left. And that's, again, in seconds, and it would start at 30 seconds and then count down to 0 seconds. So here, the distance in feet of the swing from the top beam as a function of the time that the child gets on the swing. So if I'm looking at that, the distance in feet from the swing to the top beam as a function of time could be constant because the swing is going to say the same distance from the top beam. So I'm going to put this one as function d and just say time. And then here, this would be distance from the top beam. You might also think of it as this if the swing is getting closer to the top and then the bottom. So it could be this one as well. Here, function s, the total number of times an adult pushes the swing. So I think about that as I push my son Thomas all the time. He used to do that a lot when he was a kid. Now that he's about 6, he doesn't need as many pushes. But you could do, all right, I'll start you off and push you, then I'll push you again, and then keep pushing the kid. And after a while, they get going and can swing on their own. So this would be the time. And the number of pushes, you can go like one push for, the first couple seconds, and then the second push, and then the third push. So on the dependent variable on the y-axis would be the number of pushes. So on here, we marked our points, and on the last one, we could say 0 pushes to, let's say, 1, 2, 3, 4, and 5 pushes.